Hey everyone, so this is a part two to my Boats Over the Curve video that I put out a few weeks ago, kind of documenting the various steps and processes that you would see when looking at an observation of, say, a boat appearing to go over the curve. Now, of course we know it's not, so then how do we explain things like disappearing bottom up? The boat appears to only then show at some point the sail and not the hull, etc. So I came across a video on YouTube called, well, it's just called Experimentos by Guy Flat Laura. Now, this isn't the original poster of the video. I can't find the original. The original is not in the description. And then I asked this person, do you have the original source? And she said, I don't have it. So if anyone else knows the original source, I'd like the link so I can drop this person a message. And basically what they show is the exact same phenomenon that we would see when an actual real-world boat on the ocean goes into the distance and appears to vanish. So what I did is I created a series of slides based on the video of each video. So here's a real-world example of a guy who said this sailboat was going over the curve of the Earth, and here's the video that I just showed you on the right. And there's only 4 images, and after the images I'll play this video. I'll link to both videos, but I'll play this one so you can get an exact idea of what's going on. So as we see here, right here, we have a fairly normal image. The boat's much closer. Um, well, it's close to the camera right now, respectively speaking. And this boat, it's like 20-30 feet away from the observer. Now this guy's only 3 inches above the ground. This boat, I'm not sure, not too big of a deal at this point. So we have full sailboat in view, hull, sail, etc. Here's the sailboat, sail and hull. Now, what we have in the very next shot is we see the same phenomenon of an inferior mirage. Now, we get the inferior mirage for 2 different reasons, but it's the same cause. The cause is refraction. In this one, the reason is because the boat's going farther out into the distance, and as you go farther out, the inferior mirage increases. In this one, the camera height is actually lowered a few centimeters. I think from, say, probably 3 inches to, say, in this image, maybe 2.5 to 2 inches. I'm not exactly sure, but I do know that he's lowering the camera very steadily. And when you watch the video, you can barely notice the camera's dropping. But either way, we have the same phenomenon, and the boat is starting to, on the right, is starting to vanish, even though it's on a flat surface. And even though all he's doing is lowering the camera, what that's actually doing is it's causing a greater atmospheric distortion because refraction is the strongest at the surface of whatever, well, at the lowest possible point of whatever surface you're on. And not only that, but refraction also gets worse the further out you go, as in this example. So we'll go on to the third image. So right now on the left, people would be saying, wow, look, the boat's going over the curve. All you can see is, for the most part, is the sail, and then the boat is undistinguishable. You wouldn't even know this part of it was the hull. But now notice there's still the inferior mirage line, so we know everything above the inferior mirage is the actual boat, and everything below it is the mirage. But notice on the right, okay, so here we have basically the same phenomenon, inferior mirage, and the boat is, I don't know, it's imploding into itself basically due to the refractive conditions, and that's exactly what's going on here. The boat isn't going over any curve. It's simply being hidden due to this band of refraction, just as we see here. And then finally, in the last image, wow, look, the boat, the whole hull is gone, right? Must be over the curve. Well, looky here, the whole hull of the toy boat is gone simply due to refraction. And by the way, in each of these shots, the camera on the right is successively lowered, which increases the refractive conditions, which causes the obstruction to increase to where at this point we don't see any of the bottom of the boat. It's completely formed into itself, if you will. And then on the left, the difference is distance, so the boat's relatively close, and then as it goes farther here, farther, and even further, it is the same cause. Again, the cause is refraction. In this one, the boat is going further, causing an increase in refractive conditions and just general atmosphere. It's harder to see. Notice how even this part of the sail, it's not clear anymore, whereas in this one, it's very clear. You can see lines and outlines, and by the time you get to the last one, it's just a blob, even at this point, because of the atmosphere itself. So the cause of this one is distance, and the cause of this one is lowering of the height. But really, the cause is refraction and refractive conditions. So let me go to the video, and I'll round it out with this so you can see exactly what is going on. It's really a fantastic observation, and one that fully 100% completely explains A, objects disappearing from the bottom up due to refraction, and then B, why boats appear to go over a curve
inch and a half
when they
or
don't.
so to the
Oops, let me mute. It's going lower. He's lowering the camera, and the refraction is increasing, and the band is increasing, and now the whole hole is gone. And you would say, well, that's curved. No, it's nothing changed except for the height of the camera, and then of course the refractions. When you lift it back up, clearly you can see the refractive bands changing. Like if you watch here, the refraction. Let me pause it. You can see the bands of various layers of refraction here as the heat wave off of this cement increases. And then of course you can see the bottom. So there you go.